All right, so we're going to talk about using WinDebug to do source level debugging and kernel debugging. And I'm going to use this ARM machine because it'll work fine. Uh, Now, you used to have to go to a special website to download Visual Studio for ARM, but you don't have to anymore. A couple of days ago, I did this, and all I did was use 125 here, just install Visual Studio the normal way, and it automatically detected that I had Windows on ARM and put on the right version. So the first part of this is no longer necessary. Just ordinary Visual Studio will work. And let me just get my instructions up on another screen. So we're going to make a native tools, ARM64 native tools. So you can do it by going to all programs and the Visual Studio link. You can also just search for it, but it's probably better to demonstrate all the options like you've seen before here. And here's ARM64 native tools command prompt. That's what I want. And you can also make 64-bit and 32-bit Intel code with Visual Studio, even though I'm running on ARM. So that's pretty nice. So now I'm ready to make programs here. So first I'm going to make a directory to put them in, and then go there. All right, now I'm going to make a program at Notepad. I'll call it secret.cpp and create a new file. And here's the code I'm going to put in there. Just copy and paste. All right, and what this code does, I think maybe Control Plus works here too. Very nice. All right, what this code is going to do, it's going to ask me for a password, and then it's going to decide if I got it right, and it's going to decrypt this. This is my encrypted password, and it's got some kind of decryption algorithm, looks sort of like a modified Caesar cipher here, to see if I got it right. And this is something malware does a lot. It scrambles the strings with some usually not very complex method, just so you can't easily find them with strings, just to slow down analysis. And so that's all we're going to do here. So I'll save that and close Notepad and compile it. So all I do is CL is the compiler, /EHSC is standard things. I forget what ZI does, but I like that switch for this one. So secret CPP. And now if I do a directory, it's created secret.exe and a few other things associated with it. Oh, that's what the ZI does. ZI saves the symbols in the PDB file, which is going to be really important for us. That's how you can do source level debugging and be connected to it. So we can examine the properties of this program, C127, and here's secret.exe. So if I view properties and go to the compatibility tab, it will tell me this is native for ARM, Windows on ARM. All right. So now we have WinDebug, and we're going to debug this program. WinDebug is, now we've been using OllyDebug, which is easy to use and very friendly, but it has serious limitations. It's an old program, so it only does 32-bit code, and it cannot debug the kernel. So if you really get serious about debugging internal Windows components, you have to use the Microsoft product WinDebug, which is very difficult to use. OllyDebug is much friendlier. And Microsoft recently updated this program to try to make it easier to use, and I don't think they succeeded very much. They added the ribbon and they added graphical components, but the graphical components don't actually help much. It's basically a command line tool. However, so just like Ollie, you launch the debugger and then you run the program in the debugger. So I will launch executable and go to C127 secret.exe. So there it is. And so here it is loading it. As before, it's running the program, but it stops before it executes any of the code with a break instruction and sits here. And here's the, all right, so here's the layout of these things. And now I can examine it. The program is called Secret. Notice, by the way, here's the executable search path. So it is secret, then a library, then a kernel-base.dil. So here's the components that are used. And I can now examine with the X command, secret, and bang main. That will show me the entry point, secret main. This is the address of it. And I can put a breakpoint at secret main with BP bang main. And then I can run the program. I could use the go button here or use the G command down here. That will run, and now it will hit the breakpoint at main. This, by the way, is also true of OllyDebug and other debuggers. When they first load the program, they often do not proceed to the actual start of the code the developer wrote. They stop somewhere in the Windows operating system on the way to launching it. That's why I had to move forward again to get to the real start of the program. And when I got to it, since I had compiled it with the ZI switch, it left the symbols file there and a connection to the source code. So now I can do source code debugging. Instead of having to read assembly code, I can see the source code here and it shows me what line I'm on, and I can work by lines of source code, which is of course much friendlier for developers. And down here, you see variables defined here. And see the last has some number, numerical value already, an encrypted password. I thought I could expand it, but maybe not yet. Probably because nothing's been loaded yet. I'm just at the start of main. All right. And now I can view the disassembly view. If I go to layouts, in the view tab of the ribbon, go to layouts, disassembly. There we go. Here you can see the assembly code, the kind of thing you would have seen in the code window of OllyDebug. This is ARM assembly code, which looks rather different than Intel assembly code. The most obvious thing you'll immediately notice is every command is exactly the same length, 32 bits long, whereas Intel code has a different length for various commands. All right. And so it's going to start by pushing a security cookie onto the stack. This is a security measure used almost all the time now. You push a cookie onto the stack, and then at the end of a routine, when you return from it, you check to make sure that cookie has not changed. And this is how you prevent stack buffer overflows, which we're going to be doing a lot of tomorrow. Anyway, so now we can return back to source view, back to default. Okay. And go home. And I'm just going to restart. This is something I do a lot in OllyDebug too. Whenever you lose your place, you can just restart the program again. And I can just click go because I think it remembers my breakpoint, and it did. So now I'm back to the start of the program. All right. Now, in line 20, see, I don't know how to decrypt this encrypted password. And like I mentioned before, why should I bother figuring out how to decrypt it? The developer of this malware wrote code to decrypt it. I just need to see the answer. So down here at line 20, it's done decrypting the password. And here it's putting the null byte at the end. So I'm just going to put a breakpoint here by clicking there. And now I'll run and stop at this point. And at this point, the password is in the password variable contain the decrypted password. So I just go. It's going to run and should go until it gets down there, which I'm not sure it did. I expected to see it highlighting things, and I don't see it sending. Debuggy is running. Oh, here. Okay. Now I have to give it a guess, I guess. So I put in a guess of 1. It was waiting for input from me. So I put in the guess of 1. Now it should proceed until it hits the breakpoint. It did. It now hit the breakpoint. So now I should be able to see the value of that variable here in the PWD variable. Expand PWD. And unfortunately, it does not seem to work, which is extremely rude. It's supposed to show me the value. Here's the message. Looks like this debugger on ARM doesn't work very well. So you can get this far in the project, but you can't actually get the flag, which is mighty rude. And it looks to me like I would say the WinDebug on ARM is not really up to working, although it did work when I downloaded the sort of beta version of WinDebug on ARM when I wrote this project. So That's a little bit rude. So anyway, maybe I think, did I have to download a special WinDebug? No, Visual Studio is what I have. Um, WinDebug for ARM. I downloaded it from Microsoft Store, and it should have given me Windows Debug for ARM. But all right, anyway, I am confused why this didn't work. Let's see. This is the debugger client version. Yeah, and it is working on ARM. Well, I'm confused why this did not work. Um, and this project may have a problem, but this is what happens when you're using a new thing like ARM. It was working a few months ago when I tested this, and now somehow it's not letting me see the answer. I wonder if I just go further. I wonder if I can make another step forward. Step over. Let's go forward another couple of commands. All right, now see PWD. Nope, it won't let me see the value of any of these variables, which it is totally supposed to let me see them. How rude. All right, well, I'm going to stop this one. That one seems to have developed a problem.